Okay, for the first one, I did like A, B, C, and then D, E, F.
Okay. A, B, C, D, E, F. Okay, and so A is A greater than B, B greater than C, and so forth.
Okay, well, technically, like I want to say all of them are like the same, but like I can't because like not all the tensions are the same.
All 6 of them or all 3 of them? I'm just still unclear.
What do you mean?
So are A through F all the same, or are you saying A through C are all the same?
I mean like A through C, and then like D to F because like
You say something like this: A equals B equals C, but they're greater than D, which is equal to E and equal to F.
yes.
Okay. What do you guys think? Give them some feedback on that. Emily.
Yeah, that's what I said, because I remember I asked you a question like last week, I think, and I was asking like which string has greater tension, and since it's all in like the same system, it's kind of they all have the same tension.
Yeah.
So it's like the only way they're different is because the first one has a massive 160 newtons total. Is 80 plus 80, and then the other one has a total of 80 newtons.
Okay.
So that's
So does everybody agree that this system would have more tension in its string than this one? So that makes a lot of sense. Does everybody agree that the tension throughout this string is the same?
yeah.
And then the tension, of course, throughout the string is the same. That's true. Okay, good job, guys. By the way, I was laughing because I saw this on my desk.
Oh my god.
I don't know if you're trying to tell me something.
No! Oh my god.
Just kidding.
Just kidding. I gave it to you a while ago.
Okay. So I didn't mean to make a fight. I was in a strange mood today.
I definitely did. Oh my god.
So Diego.
It's not Valentine's Day.
Oh, Diego, I should have mentioned that. No. How about on the next set?
Me?
Yeah, the next set of blocks. How did you rank the tension?
Like, don't even take my word for it. I'm really confused about the tension stuff. I wanted to ask you questions, but they want to like interrupt or anything.
Okay.
I wrote DACB. I don't think that's right.
DACB?
DACB. Don't write it in pen. Write it in pencil.
Oh, okay. So all right. Here we go. I got a pencil right here. DACB.
Yeah.
Okay.
I made you a love letter.
Now, Noam's not feeling confident about that, so why don't we give her some feedback? Yeah.
Well, what I'm thinking is that B and D are automatically the first two strings that with the most tension because
You're saying B and D are the greatest.
yeah, because they're closest to the hand, and like for B, like the hand is pulling to the right with 80 newtons rather than 50. So I figure that that's getting the most tension out of all of them. And then D, I'm assuming that's the second because I'm not sure how to I'm not 100% sure how to calculate the A and C tensions.
Okay.
But I'm pretty confident that D is the second choice.
Can anybody tell us how to find A and C, those tensions, Sammy?
Well, it says that the objects are at rest, so I think A and C are pulling back, A is pulling back with 80 newtons and C is pulling back with 50 newtons, or else one would be
Your contention is that 80 newtons this way for A and 50 newtons
yeah,
this way.
I mean, also write that in pencil, but...
Okay.
I agree.
You agree? Okay, so you've got some backing.
I think.
Yeah.
Didn't you say the tension throughout the string is always the same?
Yes. So everywhere along
yeah.
string B, it's the same, right? But then there's a different string attached between
Oh, okay.
that and the wall. Yeah.
Would there be a force pulling back even though there's no friction still?
What force would be pulling back?
Like, would be the tension force, right? So we don't-
Yeah, the tension in this string would be pulling back on this. Yeah. I agree with this analysis that if since this is not moving, it must have balanced forces. And so if you have 80 newtons pulling to the right, there must be 80 newtons to the left. And likewise
then it
here.
would be like A, B, C, D, but like A and B are equal, and
Yeah.
C and D are... Okay.
That's right.
So that's what happens.
So I think the last one you could write in pen.
Sorry, no.
I mean, I'm not even mad,
She's really mad. She's gonna bite you.
That's
Wait,
nice.
I realized the entire question.
Yeah.
Yeah.
I was thinking it's going to be equal.
Oh, well, so A and B, oh, sorry, and then I should put a greater than sign here. So these two are equal to each other, and these two are equal to each other. But these two are bigger than C and D. Is that better?
Like how? Like why is there 80 newtons on the other side?
Okay.
Like,
So I love drawing free body diagrams because they help me understand so much. I'm a visual person, right? We know that this rock is being pulled this way with 80 newtons of force. We know that there's also some weight, and there's also a normal force. But we do also know that the thing is not moving. It's at rest. And if it's at rest, right, the acceleration is 0, and the net force is also 0. And in order for this thing to have a net force of 0, there's got to be a balanced force on the other side. And that's the tension in rope A. Must be 80 newtons. That makes sense?
yeah.
Okay. Oh, guys, real quick, what about these two? What's the tension at point A?
80 newtons?
It's 80 newtons. Even though there's 80 hanging here and 80 hanging here, right? If you isolate this object as a free body diagram, right, you've got 80 newtons pulling down. Therefore, there's got to be 80 newtons pulling up. So the tension throughout that rope is 80 newtons. Okay. Crazy. Okay, and I was going to demonstrate that, and I don't think I need to. Yeah, maybe I'll do that tomorrow, because that's kind of ugly. So let's go ahead and look at the hanging weights. And this one. Okay. I'm going to give you one more buy on that, okay? So the next one is Emily Grimes.
Hi.
Hello.
Oh, the answer. Okay.
Oh, sorry. I got distracted there. Go ahead.
I put that C and D were equal to each other, and then that G and H were equal to each other.
You're saying
Like the individual, yeah, like.
C, D, G, H, so these two are equal, these two are equal, okay.
Yeah, and then for E and F and A and B, I don't know.
E,
I
F,
was-
oh, so you're this one's a stumper for you, is what you're telling me, kind of.
What?
You say you're kind of stumped here?
Like, I think that they would be equal because it's a whole system, and I don't know.
Would it be helpful for you to isolate maybe? Let's do one of these that you weren't sure about, E and F. Okay. Let me isolate the this guy right here.
You could use a heart for the diagram.
That would be lovely. Okay. So we'll make the top one a heart. What forces are acting on this one?
40.
40 newtons down. Right. How did you know 40 up? Right. Okay. So now let's look at the top one at E. Okay.
Oh.
What's the downward force there?
Correct.
You've got a force of gravity of 60 newtons,
Oh, do you want the values?
but there's yeah, right. If there's this tension here in this string of 40 newtons, it must be pulling down with an additional 40 newtons of force. Right? So I've got 40 newtons as well pulling down. What's the tension in the string going up? Yeah, 60 plus 40. Right? 100 newtons upwards.
So A and E are the same.
So, let's see, A is, and E, yes, they would have the same amount of tension. What has the most tension?
G.
G, yeah.
Just G.
120 newtons. Okay.
Right.
So wait, G? Oh wait,
G is not only supporting this weight, but it's also supporting this weight.
so it's, okay, so it would be, so G and H are not equal.
Correct.
Okay.
So the second string on all of them that are closer to the ceiling, those will be the first four.
So, okay, let's start. G was, we said, was the greatest, right? What's the next biggest force?
E.
E and A,
EA.
E equals A. Okay.
Good. Do you always write the equal part, or?
I do when they're the same. Yeah. What comes next? C, right? Okay. Good. And then
H.
B and H, they're equal to each other, right?
Are they equal to each other?
Uh-huh. And then D and F. Okay. Right? I'm glad we went through this exercise. It seems like you guys are having some epiphanies. Now the last one, I'm going to give you another minute to reconsider after the 3 things we've looked at already. Okay, actually 2 minutes to do that. There's a lot of stuff. 2:15 in fact. Yeah.
The thing that you think is random on Edmodo is not random. It's a order and it just resets every day. That's why it keeps telling the same.
Oh, really?
It's not random. There's no such thing as a random thing on a computer.
Wait, what?
So you know some computer science. I do not.
Am I just using candy?
Okay.
Except shuffle. Shuffle is never really shuffle.
So I need to complain to Class Dojo then that they
So it's really random or beats like this.